of going over this review as well. So I'm going to record some of this test review. Okay. Let's look at problem number 8. Okay. When you do this test, I haven't made the test yet, but it's going to be 30 points roughly. And it's going to have a bunch of problems that you're going to solve. Okay. And there will be some conceptual questions. I cannot stress enough, and let me point this out to you just in case. Do not communicate to any students during that test, because I'm not going to have too much time to go into all this detail. It is really important that when you're going to be in here taking the test, you do not share anything about this test or anything that you're doing or your answers with anyone else. Sometimes when I look at your assignments, I see things where I'm like, okay, I can tell so and so collaborated with so and so. When it comes to an assignment, I let it go because I know that sometimes people are struggling, they're helping each other out. But when it comes to a test and you collaborate and it's right there in front of me on the worksheet, then that creates a problem. Then two people whose stuff looks the same will be both held accountable. It doesn't matter who helped who. The person who helps someone is equally responsible as person who seeked help. Just to clarify that. So if you help somebody cheat, you're going to be held equally responsible. If you're at a college level and something like that happened, you can actually be expelled from the college or university. I knew of somebody who told me an incident where 3 or 4 medical students, after going through all the trouble in medical school, literally got expelled just because they weren't even actively pursuing they became part of this whole thing where they were cheating, and they kind of peeked over that, oh, okay, I guess, we'll also just join you guys in, and they got expelled from the medical school. So it's serious. Plus, from the moral point of view too, in a society where people cheat their way through or out of things is, eventually starts to deteriorate. So we don't want to be the people who, are part of a deterioration of a society. We want our society to get better. So we want to do the right things. So anyways, let's go over this. So first, read the problem. I can't stress enough, some of you are still not listening to me when I say show your work. Let me clarify this. If I do not see your work, I'm not going to give you points. Is that clear? If I don't see your work, and if you just gave me the answer, this is going to be a 0, because that answer alone does not interest me. I want to see how you got to it, because how do I know that somebody didn't just text you the answer and you put it there? I want to see, because when you show me your work, and if sometimes some people cheat, it's kind of obvious in the work sometimes, because they'll put a number, they'll say 5 out of 7, but their answer might be 6. And how do you arrive at, and the answer would be correct, but 5 or 7 doesn't lead to 6. So that to me raises an alarm. Okay, how did you get the right answer, but your work is totally incorrect? So I need to see that work, because this is an unusual circumstance where you're going to be taking the test online. So no collaboration with anyone else. Show me all your work. Okay, I had to stress this because some of you don't show me the work, despite of me repeating myself. This time it's going to be no exceptions. All right, so what force is needed? So you read the problem, you break it down. By break it down, this is what I mean. You write down, you make a list of all the known, unknown variables and write down their values. It says what force is needed to accelerate a 110 kg toy car from rest to 5 meters per second in 7 seconds. All these are values of particular variables. Which variables? What are we looking for? It says what force is needed. So you write down FE question mark. 110 kilogram, that means that's the mass. A kg, remember, kilogram is always a mass. And it starts at rest. So initial velocity, remember, velocity is a speed with a direction. Initial velocity is 0. And it goes up to 5 meters per second. The meter per second is the unit for velocity again, or speed. So its final speed or final velocity is 5 meters per second. Oh, I wrote it wrongly. 5 meters per second. and then the time finally, it took 7 seconds for this speed to go from 0 to 5 meters per second. And it's asking us to calculate the force. And in this problem, it gives you the hint to calculate acceleration first. So to find the force, if you look at the formula sheet, I'm not going to give you the formula sheet because it's going to be on your review. You're allowed to use your review. So look at the formula sheet on the review. And you realize that force formula is only one formula that gives you force. F equals ma. So you write that down. Now to calculate it, you need mass. We have mass, so that's good. But we don't have acceleration. That's why I gave you the hint to first calculate acceleration. Now again, you're going to go to the formula sheet, and you're going to all the formulas and see which formula will give you A, given that you have all these variables. So let's go back. There's actually only one formula, two formulas with A in it. F equals ma, but we're looking for A, so we can do this one. So you can't use that. The second one is this one. Oh, this one. This should help because we have VF, we have VI, we have T. So let's go back, write down that formula. This is what I mean by showing your work. I want to see all these details, all of them. Now plug in. 5 minus 0 divided by 7. So in this case, as you can see, so you're going to get, you can leave it as a fraction if you like, or you can put a decimal. So that's basically just 5/7, which is 0.7. Usually leaving it as a fraction is a better idea, but I don't care, honestly, for this course. So 0.7, because you avoid rounding errors. So it's 0.7 meters per second squared. Don't forget your units. Is everybody good so far? Any questions? Once you have the acceleration, you plug that into this formula. See how I'm showing the word? That you could also show that. And then you write down F equals m, which is 110, times a, which we just calculated. And then you get, for that, 78.5. I'm going to round it to 79. The units are newtons. So make sure you put your units. And then you plug it into this little box, 79. The second blank is for the units, and we are done. So problem set AS2-14 has similar problems.
Miss Naeem, on number 8, I did like the 0.71 and I got 78.1 newtons as my final answer. Is that wrong?
No, yours is actually better because you didn't round. So that's why
Okay.
it's the even better thing to do is to keep it as 5/7. Then you get even more precise answer. But like I said, for this course, we really don't care about rounding errors here. It's not like we're trying to send a rocket in outer space. But if you want here, if you want, let's just put it as 5/7. But I'm not going to worry if you round it. And then what you'll do is you will go back here. So let's put the more accurate one, 5/7. And then when you do that, times 5 divided by 7, which is 78. Well, I'm still getting 78.5, which is still, if you round it, 79 newtons. I guess you must have, I don't know how you rounded that, but yeah, that's what we should get.
Or when I rounded, I did the, I got, or the 5 divided by 7, I got 0.71 when I rounded.
Okay.
And then I times that by the 110.
And you got 78.1.
Yeah.
I'll accept that too. Don't worry about it. But like I said, I'm not finicky about that portion here. I'm more interested in knowing how, if you can solve this problem like so. So I'm not gonna, but this is the better answer if you keep it as a fraction. All right, let's look at another one of the same type. Let me see if this is a good one. Yeah, let's do this one, number 9. It's a variation on that. Again, you read the problem. Emily is pushing a sled on ice. If she pushes with a force of 4,500 Newton, how long will it take her to get the sled up to 5.5 meters per second from rest if the mass of the sled is 23 kilograms? Okay, so let me first create a little room here so I can show you the work. I'll give you plenty of room on the test. Okay, so again, make a list. F is 4,500 Newtons. How long will it take her? That means time. How long? That doesn't mean distance, right? You have to understand by reading the problem what how long means here. So how long will it take her to get the sled up to 5.5 meters per second from rest? So from rest means the initial speed was 0. The final speed is 5.5. V, remember, we use the variable v for speed, which also stands for velocity. Velocity is just a speed with the direction. And then the mass of the sled is also given. It is 23 kilograms. Remember, kg is the mass. So again, you ask yourself how we're going to proceed with this. Because the time appears, let's look at where time appears, where some of these other variables appear there too. So let's go up to the formulas. In all these formulas, the time appears in this and this. But for this one, can we use this? We don't know the average speed. We can find the average speed, but we don't know anything about the distance in this problem. So this isn't going to help us. But if you look at this first one, we have VF, we have VI. We don't have A, but we can calculate A using this because we have the force and mass. So that second one will help us. First, let's write down the second one. The plan is this. We have the formula A equals VF minus VI over T. We have VF, we have VI, but we don't have A. But if we can calculate A, then we can go back to this formula and find time. So how do we get A? We can use the formula F equals ma. That's the only other formula with acceleration in it. Plug in 4,500 equals mass is 23 times A. So I want to get rid of 23. How do I do that? By dividing it out because it multiplies A. So if I divide by 23, I can just cancel it. But whatever I do on one side of the equation, I have to do the same thing on the other side. So this cancels out. So 4,500 divided by 23, which is 195.65. 195. I'm just going to round it to the 10th. 195.7 meters per second square. All right, that's in meters, right? That's many meters per second square. All right, now I plug this back in here to see how long it will take. Now plug it in. So this is me plugging it in. So instead of A, put 195.7 equals VF minus VI. VF is 5.5 minus 0 divided by time, which is the unknown. So now, well, this 0 thing just disappears, right? It's just 55 over T. Remember I showed you this little help that if you have simple thing like this, problem like this, an algebra problem where you can cross multiply, because I want time to be up there, right? So my answer looks like T equals something. So one way to do that is you can cross multiply, but that's too much work. Remember what I said? Any two things that can cross multiply can also be swapped with each other. T cross multiplies with 195.7, so I can just swap it with that. So I end up with 5.5 divided by 195.7, which gives me, divided by 195.7, a really short time. This problem sounds a little bit unrealistic, to be honest with you, maybe not the best. I don't know, this is, yeah, it's in a fraction of seconds. It does seem like, although the speed isn't that big, it's not, it's actually pretty realistic. All right, So the speed, so the time it takes is only, it's not even a second. It's a fraction in the hundredths. It's 0.028. So I'm going to round it to 0.03 of a second. That's like almost instantaneous. Like it's going to happen so fast that you won't even notice it that much. It picks up that pace really fast with that force. Any questions? And then I will always give you those two boxes somewhere where you can put your answer like this. T equals, the first box will be the number, the second will be the unit. And that's your answer. Any questions on that? That should again help you with the worksheet AS2-14, which has similar problems. Let's do another one. So in all these problems in AS2-14, which we're doing similar problems, sometimes I'll ask you to calculate A, sometimes F, sometimes M, sometimes VF, VI, T. It could be any of those things, okay? That's why it helps if you lay out the problem and have a method going. Like, look at this 10. In number 10, and there was one where you had to add some stuff. I noticed that the problem was incomplete. I have already, by the way, posted the key to this as well, because we may not get through the whole thing. So you can look at my key as you finish.
Ms. Naeem, are you also recording this?
Yes, I am.
Are you going to post the recorded lesson as well?
Yes, and what I'll do is I'll post the recording again in the main Schoology page right under the where I have, or I'll tell you what, you know, the actual test review document, I'll post it in that assignment as an extra link.
Okay, thank you.
Yeah, let me make sure. Yeah, recording is going well there, so I'll do that. I think there was one. Give me a second to open up my, I can find my test review, which was on my desk, a jumble of stuff. Oh, there it is. This is problem 10. Yeah, problem 10, there's something missing in the problem. Can you guys add this? Add that. What is its final speed after? Or let's say at, not after. What is its final speed at 6 seconds? Okay. So what is the final?
So in this, we're trying to find VF.
We need to find VF after 6 seconds. It again starts at rest. So there's a force of 6,000 newtons. So F is 6,000 newtons, which is applied to a 200 kg object. So M is 200 kg. To accelerate it from rest, from VI equal to 0, that is, what is the final speed? VF equals question mark, right? Added T equals 6 seconds. So now that I have a breakdown, again, that helps. Again, going back to the formula sheet, you will see that VF appears in that formula. A equals VF minus VI divided by T, right? So VF minus VI divided by T. Now, again, you realize that to find VF, even though you have VI, you have T, but you don't have A. So you need to do another step. And that other step would be F equals MA, because you have F, you have M, that'll allow you to get A. Plug in. 600 equals 200. In the test, I may even break this problem into part A and B, where in part A, I may actually ask you to first calculate the acceleration. And in part B, I may say, calculate the force. Calculate VF. I may actually even do that for you, okay? Or I may give that as one big problem like this. So A, then you want to get rid of 200, so there your answer is A equals something. You divide both sides by 200. So is that okay by now? Is everybody comfortable if I just write down what you get when you divide both sides by 200? These two zeros cancel. Those two, 6 divided by 2 is 3 meters per second square. So the acceleration is 3. Remember what acceleration means? Acceleration means something is, like at what rate something is speeding up or slowing down. So this acceleration means that this object is speeding up. It's picking up 3 meters per second every second. You can actually do the next calculation without even looking into the formula. After 6 seconds, how fast is it going to move? If initially it started at rest, it's picking up pace at a rate of 3 meters per second every second. After 6 seconds, how fast is it going to be moving? Anyone?
Or on that one, it's 30 meters per second because it's 6,000 newtons.
Oh, it's 6,000. I'm sorry, I wrote 100. You're right. I skipped my zero, so I ate it up. So it's 30 meters per second. Thanks for pointing that out. Yeah, I missed my zero there. So it's 30. All right, so going back again, if it's picking up its pace at 30 meters per second every second, after 6 seconds, how fast is it moving, this object? So every second, it picks up the speed by 30 meters per second. After 2 seconds, it would have been 30 times 2, right? Well, what about after 6 seconds? Anyone? Look, every second that goes by, it picks up 30 meters per second as every 1 second. That's what acceleration means, right? It's picking up speed 30 meters per second per second. The next second, it goes up to, now the new speed here is 60, then 90.
It's 180 meters per second.
Exactly. All you do is just multiply 6 by 30 because 30 meters per second jumps have happened 6 times. It's kind of like those free fall problems we did, right? Where something is falling, it picks up pace. It's the same thing. Acceleration tells you the rate at which something speeds up or slows down. Or you can use this formula. If you want to do it in a bit more mechanical way, just plug this into this formula. And let's see what we get. So instead of A, you put 30 equals VF is what we're looking for. So keep the unknown as it is, minus VI, which is 0, divided by T, which is 6. This thing you just ignore, right? 0 doesn't change anything, subtracting 0. Again, 30 and 6, you can just cross multiply those. So you cross multiply those because there's a 1 under here. So VF is 6 times 30, which is 180 meters per second. That is your final speed. So anyway, I think I've shown you enough. The next one is kind of again along the same lines. Here, you're looking for initial speed, VI. So I'm going to let you do that. And then when you're done, you can check that with my answer key. Okay. My answer key is there. It should just check there. I want to jump into some of the other problems now. But any questions? Is everybody good? Now, what I did should not only help you with this section, it should also help you with AS2-14. If somebody wasn't sure about that, you can go back and finish your AS2-14. All the problems are like this, where either you're finding VI, T, A, F. If you follow the method and you have only 2 equations there that you're using, then you should be able to do those. I want to do this type of problem, number 12. So let's look at that. I'm going to change page number here so I have more space. So you are going to have a problem like this on the test as well, where you look at the problem and you look at all these different forces and you calculate the net force. All these arrows represent forces. Newton is the unit for force. There is a tug of war, or all these forces are either working together or working against each other. First question is, what's left behind? After all this happens, what is the actual force that causes this box to accelerate, that causes the acceleration. So let's analyze this. First of all, just by looking at it, you can see that this 20 newtons, this force and that force, they are opposing each other, right? And they're equal and opposite. So if this was like a tug of war, there's going to be no winner. So these two just cancel out. So those two just cancel out. Now look at the other ones. This 2 Newton is in the opposite direction to this 2 Newton. Those also cancel out. The net force in this problem, F net, is only 4 newtons. That's the only force that's on the really affecting the box. There's another way to calculate that too. If you look at these two forces, they add up to 6 Newton, and that is opposing a 2 Newton force. The net force is the difference between those two. 6 minus 2 is 4 Newton. That's another way to think about the net force. So the net force is the residual force. The direction of the net force is always in the direction of the winning force. Which side is the winning side? It's this side. That's the winner by 4 newtons. So which way is it acting? To the right. That is the direction of the net force. That is also going to be the direction of acceleration of this box. This box will pick up speed in that direction. Any questions on that part? Okay. So if the mass of the body is 2.5 kg, calculate acceleration. Again, write down the information that you have. You're given m. M is 2.5 kg. We also know from up here that the net force, F net or F, is 4 newtons. How do we calculate the acceleration? You go to your formula sheet. It's that same equation that we used in the previous ones, right? The one that has F, M, and A in it. Is that the equation for second law, Newton's second law? F equals ma. So write down the equation. I can't stress enough, write down the formula. Because when students just look at a formula and they try to just plug in and quickly skip a step, they're more likely to make mistakes, I've noticed. Like they'll put the wrong number somewhere. And if you have the equation written down and you plug the numbers right under it, you're less likely to make that mistake. I actually make more mistakes when I don't write the formulas down because I'm a bit absent-minded, so I'll mess things up. So under M, I'm putting the value for M, and A is what we're looking for. This should actually help you with one of the other worksheets if you haven't done that yet, the one on net forces. All right, so how do we calculate this? Then you want to get rid of 2.5, so you divide both sides by 2.5. So the acceleration will be 4 divided by 2.5, because on the other side just cancels out. And you get 4 divided by 2.5, which is 1.6 meters per second square. The units for acceleration are always meter per second square. So let's fill that in the blank. Any questions so far? What's the direction of acceleration? The direction of acceleration is always the direction of the net force. So this answer is always going to be the same as this direction, right? And we're done with that too. So I give you 2 concept rulers, which obviously I'm not going to post the key for. You actually do those, they will help you because some of you, I noticed when you turn in one of your assignments, I think AS2-15 was it? No, not, I can't remember. There was a one where you had to do an interactive. Some of you didn't do it all the way. And some of you got a 1 out of 10 because of that. Because when I looked at it and I was like, well, if you actually did the interactive, you would have checked your answer. So if you checked it and you just gave up, then you didn't do the worksheet. You didn't do the work, all right? So if you have a 1 out of 10 on that worksheet, I'll tell you guys who needs to redo it. Then you need to redo that. You actually need to do that. Put the correct answer, resubmit, and then send me an email if you would like me to give you the grade, and I'll still give you the full credit if you do that before the test. Now, this concept builder, I just want to let you know that when you actually play with this, any type of a problem where it says, let's say that a box is being pushed on the floor. So let me remind you, let's say that I'm just going to do one example, that a box is pushed on the floor. Remember the different forces we talked about? One was the force, applied force. That's the one that you apply to push a box. So FAPP is sometimes how we write that. If it's on a floor, then there's friction. Friction is always in the direction opposite to the applied force. Fric. If the box is accelerating to the right, that means F applied should be bigger than F friction, because there's a net force, which is not zero. The forces are not balanced. If the two arrows are equal and opposite, then you're pushing the box either at a constant speed, or the box is not moving at all. You're just pushing it. You're not pushing it hard enough to overcome friction. There are more forces, by the way. The other forces include the earth is pulling the box down, which is the weight, or F grav, force of gravity on a body is its weight. If this box is not sinking into the ground, if it's not mentioned, then you don't assume that. Then there's a force keeping it afloat. That support force comes from the floor. We call it normal force. Remember the normal force? F normal. That's usually always equal and opposite to F gravity if things are not accelerating vertically. By the way, if an object is falling through air, there is no normal force. Normal force only happens when one object is pushing on another object or a surface. If you push a wall with your hands, if your hand doesn't sink in, then there is a normal force on your hand. So do not confuse. The normal force isn't going to be there if some object is simply just falling through air, if a football is flying through air, if an elevator is being pulled up, then it's not normal. Then it's other types of forces. Any questions on that? Oh, one other thing. I noticed that the concept builder also gives you air resistance. So anytime something is moving through air, you will also mention air resistance. So F air is what I'm going to call it. It gives you the names of all the forces that are acting. And air resistance will always, they do want you to put air resistance. Otherwise, you're going to get incorrect answer. I'll also mention a few other forces. Anytime an object is flying through air, you're going to have air resistance. That's another force I briefly mentioned. If you are pulling a bucket with a rope, anytime you see the word rope or a string involved, then there's the tension force. You don't call it applied force, but you're going to say that this is being pulled up. If it's being pulled up using a rope, then there is tension force in the rope that is indirectly. Your applied force indirectly acts on the bucket. So you don't mention applied force. You only mention tension. And you're going to mention the weight. F grav. Let's just call it F grav, which is the weight. This is the weight, by the way. The force of gravity, the concept builder calls it just gravity, force of gravity. Force of gravity, weight means the same thing. So you're going to do this. There are 3 concept builders here. And then you're going to do this, 3 concept builders here. I'll tell you what, on second thought, I'm thinking I'm going to give you opportunity to do extra credit. Instead of this being a regular credit, I'm going to turn this into an extra credit. And I'll tell you what, those of you who have 100% on all the assignments have an opportunity to put 5 points of extra credit towards your test. If you don't have 100%, then I will give you 10 points of this test review towards any missing assignment scores. But you have to first do that assignment, get the partial score, which is usually 70%. And then you get the partial, I'll give you the 10 points towards low assignment scores. So I'm going to give you this opportunity to help you a little bit. Some of you need it more than others. All right, so now I'm going to let you work, because these are easy now. For the problems I showed you, these are actually simple ones. So you can look at my, this is what I want you to do. Do this. Every time you do a question, check your answer with my key. If you see that it's wrong and you don't understand where you made a mistake, you need to ask me. But everybody needs to stay connected through Zoom, because I also need a little time to talk to some of you, okay? So go ahead and get started. I'm going to change that thing to extra credit now. And I'm going to stop the recording, and after the class is over, I will post the recording of what I just discussed as a little link. So if you have a friend, if anybody knows Anthony, I know that he had to go somewhere, I think on a funeral or something like that, then you might want to tell him about there being a recording that he can, you know, do him a favor, tell him about it. Okay.
So do we have to do number 13 and 14?
So if you don't need extra credit and you don't care, you don't have to. Because if you
Okay.
already and you do well on the test, then you're good.
Okay.
So at this point, yeah, you don't have to.